Hello, in today's lesson we are gonna explore ways on how to solve systems of equations. Now the technique that I'm going to show you is by either substitution or by linear combination. But before we get there, let me show you what happened when we try to solve a system of equations graphically. Each equation represents a line, so our goal is to find the intersection of the two lines. When the two lines intersect at one point, we say the system has one solution. And sometimes that's referred to as consistent. And our goal is to find that point of intersection, which is referred to as an ordered pair. Other case that could happen is the two lines happen to have the same slope and they're parallel to each other. And if that's the case, then they don't intersect anywhere. Therefore, we say the system has no solution. And another way of saying that is to refer to as inconsistent. The last case is these two lines happen to be the same line, so they overlap, and therefore we say there are many solutions to the system. Okay. All right, so we're gonna solve systems of equation by algebraic method instead of by graphical method. But I just want you to take a look so that you can understand what it means to graphically how a solution is represented. All right, so let me erase this. Okay. So the first method that we're gonna go over is by substitution method. So consider the following system. Okay. First equation is x minus 2y is equal to 5. Second equation is 4x plus 3y is equal to 9. Alright, so when we solve by substitution, okay, by its name, the goal is to substitute one equation into the other. So here's what we're going to do. The first thing we're going to do is we're going to pick one of the two equations and solve for one of the variables. So I'm going to pick the first equation and solve for x just because it looks easier out of the two. Okay, so let me write down the instructions so that you have it. So solve one equation, okay, for one of the variables. For one variable. So if I solve for x, add 2y to both sides, the first equation is going to look like this. If you add 2y to both sides, then you get x is equal to 2y plus 5. Alright, so that's the first thing you do. The second thing you do is I'm going to go ahead and substitute this value into the x from the second equation. So substitute 2y plus 5, 4x in the second equation. Alright, so here's what it's going to look like. The second equation, I'm going to replace that x with 2y plus 5. So I get 4, 2y plus 5 plus 3y is equal to 5. Alright, distribute and solve for y. I get 8y plus 20 plus 3y is equal to 5. Okay, I'm going to subtract 20 to both sides and then combine the 8y and the 3y together. So 8y plus 3y is 11y. Subtract 20 to both sides, that will bring me with negative 15. Okay, so y comes out to be, oh, I think I did something wrong here. Let's see. Oh, sorry. I copied down the 9 is supposed to be here. See, the second equation contains a 9. So that should have been a 9. Okay. And then when I subtract 20 to both sides, I should have got negative 11 like that. Okay. Now divide both sides by 11. Y comes out to be negative 1. So y is equal to negative 1. Okay, so good. So we use substitution, we found y. Now we're going to solve for x. So the next step is, okay, substitute negative 1 for y into either equation. um, and solve x to find x. Okay, so I'm going to go ahead and replace either equation by -1. So I'm going to choose the first equation because that seems the easiest. So the first equation, x minus 2 times -1 is equal to 5. If you do the work, this becomes plus 2. If you subtract 2 to both sides, x is going to come out to be 3. So the solution for these two lines is 3, -1. That is where the two lines will intersect. Alright? That is the substitution method. I'm going to go through another problem and I'll show you a different method to solve systems of two equations. Alright. Now the next method that we're going to go over is called linear combination. So here's number 2. The problem here is 3x minus 4y is equal to 14. Second equation, 4x plus 10y is equal to 11. And we're going to use the method called linear combination. Okay. In linear combination, and usually we would use linear combination when the systems of equations are in standard form, like each equation is in standard form. And sometimes it's best to use linear combination. Most of the time, linear combination would be the quickest method. So what we're going to do here is, our goal is to eliminate one variable by adding the two equations together. Notice that, say if I want to eliminate the x variable, then both of their coefficients have to be opposites from each other. In other words, in order for the x variable to go away, if the coefficient here is 12, then the coefficient down here has to be -12. Alright? And so to get the coefficients to be, first of all, kind of somewhat the same, what we're going to do is we're going to multiply the first equation by 4. And then multiply the second equation by -3. Alright? So here's what I'm going to do. Multiply the first equation by 4 and the second equation by -3. Alright? If I do that, here's what the first equation is going to look like. Multiply that by 4, I get 12x minus